this being the first session on triangles. Welcome to that session. The first we start with the theorem 1, that is the basic proportionality theorem, which is also known as Thales theorem. I'm not writing the basic as what it is called, that is basic proportionality theorem. We'll read the statement in it. The theorem says if a line is drawn parallel to one side of a triangle intersecting the other two sides, then it divides the two sides in the same ratio. So what it means is, we draw any triangle, suppose. We will be proving this statement, how this theorem has been derived, that if a line which is drawn parallel to one side of the triangle, this is the triangle which is named as A, B, C. Now we are drawing a line which is parallel to one side. I'm drawing a line, this is parallel to BC. This is parallel to BC and I gave it a name of DE. Now this DE is parallel to BC and intersects the other two sides. That means DE is intersecting AB and AC. Then this line DE is dividing the other two sides, which is AB and AC, in the same ratio. That means AD by DB is equal to AE by EC. That's what we have to prove. Now to do so, we will join BE, we join D with C, and we draw perpendicular from E to the line AD and perpendicular to the line EA from D. So they would look like, I'm drawing a perpendicular. This is F, EF and DG. These are the two perpendiculars we have drawn now. Since EF is the perpendicular to AB, therefore EF becomes the height of the triangle ADE, this one, as well as for DBE as well. This EF becomes the height of ADE as well as DBE. On the other hand, DG now becomes the height of ADE and DEC. Now how do we find area of triangle ADE? Area of triangle DBE is again half base into altitude. So what's our base? Base is this AD and height becomes EF. So AD into EF. Sorry. On the similar note, what is the area of angle DBE? This one, DBE. This is also a half. In this case, base remains DB, but the height is again EF. we have to see the proportionality. So area of ADE by area of DBE. So I'm not writing it again, I'm just simply drawing and giving it a fraction form. Thereby this getting cancelled, this getting cancelled, we are getting AD by DB. This is the first thing we get. On the other hand, if we look at ADE, it can also have DG as its height or the altitude, sorry, and DBE can also DBE, no, AD, sorry, AD, oh yeah, ADE as it's got DG as their height. DEC will also have DG as their height, as we just mentioned this when we were starting and reading the figure. So we'd write area of triangle ADE by, I'm directly writing as in the proportion format, in triangle DEC. This ADE is half, base is AE, but the height remains DG. Here it is DEC, so the base remains EC, and the height will again be DG. So here we are getting AE by EC. Now if you look at DBE and DEC, they are drawn on this common base DE, and also between the parallel lines DE and BC. So what does it say? If the two triangles are drawn between two parallel lines and are on a common base, the area of these two triangles are equal. So AD by DB, area of these triangles to be similar. Oh, I made a mistake, sorry. So I write area of triangle DBE is equal to area of triangle DCE. These are all about area. If I write 1 by area of DBE, taking the reciprocals of both the sides, DCE, as because I need this kind of representation, I am multiplying ADE to both the numerators. So I am getting, once doing so, I will be getting ADE by DBE. Though I didn't write, you can remember that I'm just multiplying a common area ADE to both sides, is equal to ADE by DCE. Now area of ADE by DBE was given by AD by DB from the first equation, and area of ADE by DCE from the second equation makes it AE by EC. So this is what we were to prove here. So now you remember the proportionality theorem, wherein there are the lines are drawn to one side, it is intersecting the other two sides, then the sides are divided in the same ratio. We also will now be taking up the converse of this theorem. Sorry. What does the converse theorem say? I'd write it first. If a line divides any two sides of a triangle, though I missed it, of a triangle in the same ratio, then the line must be parallel to the third side. There we were drawing, oh, this is, it looks parallel to the third side. And previously we had seen that we were drawing the line parallel and proving them to be proportional. Herein the proportionality is given and we will be proving the lines to be parallel. Now this theorem is proved by, it is called a kind of what do you call? I'll just draw and tell you. It shows, first you will take up that it is not parallel, and then you prove without taking it parallel. If it isn't working, then how it has to be parallel. Let me just figure it out. This is a triangle. I'll not spend much time on it drawing this. This is similarly as we had taken in the previous one, A, B, C. This will be D, sorry, E. We have to now prove this DE is parallel to BC. It is given to us AD by DB is already equal to AE by EC. Now we have to think that DE is not parallel. That means I draw a line which is not parallel, maybe like this, a little above it. That makes it, and it's also intersecting at a point which is F. Now we draw DE not parallel to BC. So since DF is parallel to BC, so we are assuming DE is not parallel, so DF is parallel. In that case, if DF is parallel, we will write AD, that from the basic proportionality theorem, AD by DB should be equal to AF by FC. But it is given AD by DB is equal to AE by EC. This also, from this two, it shows the right side should be equal, that is AE by EC should be equal to AF by FC. So AE by EC should be equal to AF by FC. Now I add 1 to both the sides. If I add 1 to both sides, thereby making it AF plus EC by EC equals AF plus FC by FC. Now AF plus, this AE plus EC is AC. So I write it AC by EC is equal to AF plus FC. This is AF plus FC. That also makes it AC by FC. Thereby, if this is true, then EC should be equal to FC. EC should be, but this is possible only when F and E are coinciding, but they are not. So DF, because we have taken DF is parallel to BC and this is not being proved, that means DF is not parallel to BC. So that is a kind of false. It's a false assessment on our part, or false assumption on our plan. So DE is parallel to BC. This is, kind of a rational proving, when you assume something is not rational and try to prove and get the resultant answer that it is irrational. Similarly, we are doing here that we are first assuming DF to be non-parallel to BC, and later on going on to prove that how DE is actually parallel to BC. We will be taking a few questions on these proportionality and the converse of proportionality theorem, that will make your understanding of the theorem quite clear. Thank you.